All right. Well, we will take a look. Today we are looking at we will look at working with files. So we've been dealing with different data structures in Python. We looked at lists and tuples and dictionaries, and then we also introduced NumPy arrays. There's another one that we'll look at. That's the data frame from pandas, but today we'll look at kind of working with files. And so, when you're dealing with data in Python, a lot of times you will deal with, say, CSV files. Okay, and that's pretty standard. But the discussion of CSV files will come later when we're talking about data frames and pandas. Today I just kind of want to talk about files for other types of output or other objects in Python, not necessarily a table of data, and so that's what we'll take a look at today. Okay, working with files. All right, so this just kind of at a very basic level, we want to talk about this concept of persistence in that. Basically, whenever you run code in Python, it is generally considered transient in that while it's running, those variables exist in memory. And, as you're running your files, in VS Code, you can kind of check, what variables exist and you can kind of pull up their values and whatnot. But then as soon as you kind of quit and you exit, that Python kernel shuts down and those values are lost. Okay, so if you want to kind of reuse any of these values, you need some way to kind of store them, right? And so we can write things to a file to basically to save data. Okay, all right. So we open a file using this command open, okay? And this is part of base Python, and this just kind of allows us to interact with files, and kind of your most kind of basic command is going to be open, and then you give it the name of a file. So I'm going to call this output.txt, and then you give it an argument which will describe how Python should work with this file. And so in this case, my argument is going to be W, okay? And that means I'm going to open a writable connection to this output.txt, okay? If the file already exists, open with a W is going to just basically delete whatever's in there and replace it with whatever you're doing here, okay? If you don't want that to happen, you got to basically use different arguments, okay? If the file doesn't exist, then this will be created. So here, open output.txt will either open the file output.txt if it exists and basically wipe out the contents, replace it, or it will just go ahead and create it, okay? And we're going to store this connection, this open, and we're going to call it fout, okay? So so here, and then if I ask what is fout, okay, it'll say this is an input-output text I/O wrapper, okay? And so this is basically just saying, and the mode is write, okay? And this is just saying this is basically a connection, an input-output connection, I/O connection here, okay? And so what I'm going to do is what we can do is we can call fout, okay, whatever this connection is, fileout.write, okay? So here I'm going to call, I want to take this connection that I have, and we're going to call .write, and what I'm going to write is, you can write basically whatever you want. So here I'm going to write line 1, and line 1 is just some string, okay, that just says this is the first line of text, okay? And when you call fout.write, or your connection, and you call .write, it returns basically the number of characters that were written. If I say line 2, we're going to do fout.write, and it will be the second line of text here. We'll run that. It says it's added more characters. And then when we're done, we're going to go ahead and close the connection. Okay, we're going to do fout.close. Okay, and then so now if I go over to my if I come over here and I go to output.txt, we can see these lines of text. Okay, this is the first line of text. This will be the second line of text. These things have been written to the line here. Okay. Let me go back, and I just want to kind of show what happens. So here I'm going to run this again. Okay, I'm going to open up a connection here, and if I try to open this here, it's empty. Okay, it's empty because I've opened it up again, and it has wiped it out. And again here, let me see. It may or may not let me open it up as I'm writing things to it. Okay, so right now, because the connection is open and I haven't closed it, even after I ran this, this is the first line of text. Here I can run this. This is the second line of text. I'm going to go ahead and just run it again, and you can just, and maybe I'll run it a third time, okay? And so each time it's running it, okay? And here, now it says the file's been modified, and I can open it, and you can see every time I ran, you know, this will be the second line of text. It appended that to the file there. Okay? Now, this business of doing file open, and file close, it can be a little bit annoying. So we can do, say, we can use this command with, okay, this with keyword. And then here we're going to do with open, and we open the connection again, and we're going to do it as file. And then now it will do file.write line 2. And then once it reaches the last line here, when the with ends, Python's automatically going to close the file. So I can run this again. So I can run this here, and it will basically replace the file there. Okay, and open and close it. So with will open and close. Okay, another thing, instead of writing, you can do R. Okay, R is going to be to read, and then so I can do with, and it will open it, and then it will go through, and we can iterate through each item in the file, and we can kind of print out each line here. This is the first line of text. This was the second line of text, and we have all of that. Okay. When we use this command, the method write, okay, as in file.write, okay, however we have, the argument that we pass has to be a string, okay? And if you want to use something like a number, a float, you have to convert it to a string in order to do this, okay? If I try to do something like x plus, is my favorite number here right now. X is a float, 42.3, and this is going to cause problems, okay? It's going to say you can't do addition between a float and a string. So what I can do is I can convert 42.3 to a string by wrapping it in the function string, okay? So take X, turn it into a string, and then I can do plus, and that will kind of join text together. And this produces the output here. 42.3 is my favorite number. And then I can kind of then stick that in as an argument to save to a function, or to save to a file. Okay. Another thing that we can do is we can kind of use strings with placeholders, right? So in Python, if it sees these curly braces, it treats these as basically placeholders where you can kind of, they're like fill in the blanks, okay? So you can imagine, just, some kind of paper where there's blanks for you to fill in. Basically, these curly braces are replacement fields, and they act as kind of fill in the blank spots, okay? And then so you take that string, and then you call .format, and anytime you have .format, you put in some argument here, and that argument gets fed in to that fill in the blank. Okay, so x is going to be 12.34, and then so I have this string, which is going to be fill in the blank is my favorite number, dot format x is going to go into that blank, so it's going to say 12.34 is my favorite number here. Okay, you can have multiple blanks. Okay, so you could have blank is my favorite number and blank is my second favorite number. Okay, and then when you call dot format, you provide multiple things here, x and x2. So here I've got 12.34 for x and x2 is 37.8. Okay, all right, and it will, again, it'll just kind of fill in those blanks, as we expect. Okay, you can, if you want, you can give these fill in the blanks like names. Okay, you can give it index values, I should say, maybe not names. Okay, so here this is kind of blank is my favorite number and blank is my second favorite number. Again, my favorite number is blank. But here I give, inside that curly brace, I put in a 1. Okay, so this will be index 1. And basically when I call dot format on that string here, the x2 is in position for index 1. So it's going to fill in 37.8 anytime it sees index 1. And then it's going to put in 12.34 anytime it sees index 0. Okay, so when I call this, it's going to say 37.8 is my favorite number, and 12.34, which is in position 0, is my second favorite, and then my again my favorite number is this. Okay, so that gets filled in as expected there. Okay. In these fill in the blank spots, you can also provide a colon. Okay. And the colon can put in format specifications here. So there's more on this in the format specification mini language, okay? And it will say format string syntax, and it gives you kind of all of these things in terms of, how does a replacement field work? You got the curly braces, the field name, the format spec, okay? And it says, see the format spec specification, okay, and you can do basically these types, and these are the different arguments that you can provide as far as the type and the precision and all of that. So this is, you have some of these different formats here, okay, E and F and G and things like that. G is the general format, okay. And so there's all kinds of, there's a bunch of different examples here, okay? So for example, okay, I don't know why it keeps, okay, so it says, the default is to round to 6 significant figures. So just to kind of illustrate this, I have x is 0.000, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then x2 is 4 leading zeros, 0.0000, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then so 0:g will, I think, default to round to 6 significant figures. Okay, and so I think because it's got the leading zeros, I think if I'm not mistaken, it'll say 1.2345 e negative 4 or something, and then here I'm going to do dot 8g, and this will say I want to keep 8 significant figures. Okay, okay, so here I guess it'll print 1, 2, 3, 4, 5, 7, so rounds that 6 off. And it prints it out 0.000 here. But over here, 1.234567, that 8 gets rounded up to a 9, and then it says E minus 5. So this is just kind of how it prints out there, okay? F is going to be a fixed point format, okay? And so fixed point format, it's not going to do kind of the scientific notation here. So if I do : F, then 6 places is going to be default after the decimal, so it's going to be 0.000123. F is for fixed point, and then .8f, it's also a fixed point, but it keeps 8 places after the decimal, so 0.000123.4, but that 4 gets rounded up to a 5. Okay, we've seen this. You can do, if you don't want to use the format strings with the curly braces and the fill in the blanks, the replacement fields, you can just kind of concatenate, like a Lego bricks or something. You just kind of fit them into the string wrapper, and then and you'll do like, my age is space plus whatever the number, 85, plus comma, space, and space. Okay, blank is my favorite number. Okay, and then instead of kind of doing this business here, you can create placeholders, right? And here I've got 3 replacement fields, and in order we're going to do Joe Broen 183. Okay. Okay. And these are more examples directly from the Python documentation. So I've got curly brace 0, curly brace 1, curly brace 2. We're going to put in ABC, and we're going to just get ABC. Okay. If you don't put anything in there, it'll go in respectively. All right. So this will be ABC. Here, if I do 210, this will output what? CBA, right? Okay. And 210, and notice what I do here. Okay. Here I have star ABC, string ABC, and what this will do is this will just unpack. Okay, remember tuple unpacking? It can also be done with things like strings. Okay, so again, strings are treated as basically an iterable of individual characters, and so if I do star quote ABC, this will just unpack them into ABC, and so we will get the same result, CBA there. Okay, and here. If you do abra and cad and you do 010, you'll get abracadabra. So it's just kind of some silliness there. Okay. So you can repeat indices here, 0, 1, and 0. Some of these things can be named, which can be handy for things like this. You got coordinates, latitude, and longitude. And then you can put in basically like a dictionary here, okay? Well, okay, here I've got keyword and argument, keywords and values. Latitude equals 37.24, longitude is equal to -115 W, okay? And it does that. Here I've got a dictionary, okay? A dictionary with latitude and longitude specified. And so what I can do here is I can do .format, and then instead of providing the keywords and the values, I can take the dictionary and I can unpack it. Okay, so this is called KWARG, or keyword argument unpacking, and here it's basically the same thing as like tuple unpacking, except because I've got both keywords and keys and arguments, okay, keys and values, I use 2 stars, okay, and so this will unpack it, and it will do that. If you only do 1 value, then we run into a problem, okay? It says, it's getting a key error. It's looking for something called longitude, and when we unpack with a single star, I think it doesn't quite work for this dictionary here, okay? So we use two stars there. You also have these text alignment options, okay? And again, these are provided in the format specification language here. You know, as far as the alignment operators, you've got basically to the left and to the right for less than and right, greater than signs, but basically kind of like pointing to the left and pointing to the right. And so here you can do left align 30 means that I want a total of 30 characters. Okay, and so when I run this, we get left aligned and then a whole bunch of trailing spaces so that the resulting string is 30 characters wide. Okay, over here I've got right aligned, space here, centered, we'll have that. Okay, and so if you wanted to write a file, sometimes you want to have a file that when they open up is a certain width or whatever, you can use some of these arguments here. Okay. All right. Let me give you your. Oh, okay, wrong page. Okay, view quiz answer. Sorry. Okay, week 4, Wednesday. Okay, first answer is A. A as in apple. A as in apple. Okay, there's a module called OS. All right, so here, I got to give you a warning. If you ever download a script on the internet and it has OS in there, it says import OS, okay? Don't just run it, all right? You got to be real careful, right? Because you don't want to grant Python the ability to just start messing with files on your computer, okay? So basically, you can give Python instructions to start interacting and changing files on your computer and things like that, okay? You're writing the script yourself. You can do it, just don't do anything stupid that you're going to regret later. But especially if you download something off of the internet, be careful. Even, places like Stack Exchange are pretty good in that, like, if somebody posts up malicious code, the community will recognize it and delete it and things like that. But if you're on, some less trustworthy forum or somebody could, as a joke, post some, it's not a very funny joke, but they could post some script and they'll say, hey, just run this and it'll fix your problems, but it'll say something like import OS and then delete all of these files and things like that. So just be very careful before you just start running some random stranger's code, okay? But anyway, import OS is gonna basically give Python the tools to start interacting with files on your computer. So again, be careful. Just be careful before you start doing things like this, okay? So you have things like os.getCWD, get your current working directory, and this will tell you kind of like where you're working. And so right now, I store all of my stuff in users miles OneDrive teaching 21. And this is in the 2024 file, stats21 file. Your thing might be something like, your home directory /desktop /2024, whatever, however, wherever you have this thing downloaded is probably where it's going to be. Okay. You can also kind of take the file name of something and you can ask for what is the absolute path, okay? Because in general, output txt, this is what we call a relative path. It's inside the current working directory, so we can refer to a file within the current working directory as just output.txt. But if you want the absolute path, you can ask for things like that, okay? There's a whole bunch of things that can be done with Python here. We're in 3.12, and I think most of these things are pretty similar. So you can ask for things like os.name. Okay, and so I'm on a Windows machine, and so the Windows name is NT. Whereas if you're on Mac, I think it'll say POSIX. Okay. And you have different kinds of things like this. os.uname, let me see. I don't know what that is. No. It doesn't like that. os.uname. Okay, so I don't know what that is. But more a whole bunch of these different things, right? So os.environment and change directory, get your current working directory, things like that, okay? So some of these basic things we can check to see if a path exists, all right? We could see, is there a file called memo.txt? We get that back a false, okay? Is there a file called output.txt? That comes back as true, okay? Is output.txt a directory? Is directory is the thing that we can do. That says no, it's not a directory, okay? But within my thing, I have a directory called .git, okay, which keeps track of, you know, the changes in Git, and so that says, is that a directory? That comes back as true, okay? And you can kind of list off the contents of your directory by doing .list directory. Now, if you're in your, if you are in your kind of the 2024 thing, you'll probably have all of the different lecture files, Jupyter notebooks, and these different kind of files there as well. But if you're like in your downloads folder, you're going to have a whole bunch of other stuff, right? And you can put in some kind of path, right? So here's .list directory CWD for the current working directory, wherever you have, okay? We have some functions here that help us deal with problems, okay? Deal with errors. And so if I try to open something, if I try to open a file that doesn't exist, so I'm calling open bad file. There's no file called bad file. This is not going to work, okay? So when I call this, Python gives an error. It says no such file or directory, bad file. Okay, that's fine. Okay. We have a pair of keywords, try and accept. Okay, and basically this is just these are commands that we run. Where basically we tell Python, try doing this, and if it can't, okay, if it runs into a problem, then return the accept. Okay, it's kind of like an if and else, right? It's like if this, then do that, otherwise do something else, except it's for like when you run into an error, okay? If first try this, and if you can't and you run into an error, then give me the exception, okay? And so here, the accept comes back with a message that says something went wrong. So the difference here is that this raises an exception. We get something that looks like an error message. Okay. The try and the accept. Okay. The accept portion. Now you can say raise. Okay. Raise is a way for us to kind of raise an error, but you can also have it do something else. Okay. And so here this would have resulted in an error, but because it ran into an error, it runs the code in the accept part. The accept part runs some other code. Here, it just prints out a line that says something went wrong. This is not an error. This is just the alternate code here. Now, you can put in raise some kind of error and you get the error message, okay? But you can also just have it run something else entirely. So basically, you can kind of do if you're trying to open a file, you can say, hey, open the file, and if that results in an error, then create the file, okay? Something like that, right? So back here, we have this thing which was like, make this file, but we just said, hey, write the file, which means if the file already exists, it's going to get overwritten. So you might want to do something like, hey, try to read the file, but if this results in an error because it doesn't exist, then go ahead and create the file or something like that. So it's just kind of like, try this, and if you can't, then run other code. Don't necessarily give me an error. So that's when we use try and accept. Okay, we have a structure called a DBM, okay? A DBM is like a dictionary, okay? It's like a dictionary, except you can write the DBM to a file on your computer, all right? So we import a module or the library called DBM, okay? And then we're gonna open a connection to some kind of file here. So we're gonna create a file called captions, okay? And the C option is going to create it if it doesn't exist. If it does exist, it's not going to, it won't overwrite something, okay? And so here I'm using examples from the textbook, and again, the author of the textbook is a fan of the Monty Python kind of comedy group, and he's imagining this DBM to be kind of a listing of file names and captions, okay? So this is like, we're gonna create a thing called captions, and basically we're creating like an entry in a dictionary, okay? So in a dictionary, if we wanted to create a new entry with one keyword and a value, okay? Here the keyword is gonna be cleese.png. So this is just an arbitrary thing. It's not necessarily a file that actually exists or anything. It's just some keyword and the corresponding value, okay, is going to be photo of John Cleese, okay? So that's going to create an entry here. And then if we want to retrieve it, we use it just like a dictionary. We say, hey, what is the value associated with this key, okay? And so it comes back and says, okay, the value is, it says binary mode, okay? Photo of John Cleese, okay? I'm going to add another key value pair, okay? And so I've got two entries. Okay, again, it's just like we're working with a dictionary, okay? And then if you want to delete entries, you can call delete and things like that, but we won't, right? And then we can kind of go through each of the keys and just print out what we have. We can print out the key and the value. And so right now, oh, you know what? My thing says this thing called list. Here, sorry, let me delete the list, because later on I create the list. Okay, so let me delete that. Okay, so this is what our dictionary looks like right now, and then I'm going to go ahead and close that. Okay. And so when you do that, it creates these files, okay? It creates captions.dat and captions.backup and captions.dir, okay? So these are the things there, okay? Creating captions DBM, this will now include, add some things in there. And so we can just say, hey, list off everything in my current working directory, and if it contains captions, list them off. And I think it's going to create these three files, okay? These three files on your hard drive. So one of the, when you're dealing with a DBM, okay, it's only allowed to store what we call byte objects or strings, okay? So, in a dictionary, you might want to put in lists and things like that. You can put in, as far as the values go, you can put in lists. Oh, here, let me give you your second answer. Second answer is A. A as in apple is going to be your second answer for today. Okay, so if you wanted to store something other than a string or a byte object into a DBM, you have to what we call pickle them. Okay, so I don't know. It's kind of a silly thing, but it's just kind of like if you wanted to store food for a long time, one way to kind of preserve the food is to pickle them, and then you can kind of store it. And so it's the idea of like if you wanted to store a certain kind of data structure in this DBM, you have to pickle them. And what that will do is it takes the data structure and it converts it into some machine readable string, okay? So when you look at it, it's a string and it just won't make sense, okay? Not to a human. But then the computer reads that string in and then it can unpickle it and kind of recreate the original thing, okay? So here I'm going to create a list. We're going to call this T, and it's, whoops. What did I just do? Okay. All right, so it's going to create this list T, okay? And so that's a list. Now, if I try to store that list T into the DBM, so I'm going to open up my DBM, okay? We're going to call it captions, and we're going to open up that connection. If I try to store it in there, I get this error. It says values must be bytes or strings, okay? If you try to do db list equals T, we'll get back this error. It says you can't store a list into the DBM. So we run this, we import pickle, okay? Import pickle is going to bring in the functions that allow us to do this, okay? And the function we use is called dump s, okay? It seems it's kind of a funny name, okay? But we call pickle.dump s, okay? And what this will do is it will convert whatever object you want. So in this case, we want to convert the list, okay? The list object T, we're going to call dump s, and we're going to store that into a string s, okay? And so if I ask what is s, it comes back as this, okay? So remember, T is a list containing the values 1, 2, 3, okay? When you call dump s, it converts it into this string, /x80/x04/x95. And this is not really readable to a human, but the computer can read this and will understand that this is a string representation of that list containing 1, 2, 3, okay? And so now I can take this string s, which has all of this in here, and now I can store it into the DBM. So I'm going to do DBM list equals s, and then we'll go ahead and close that DBM, okay? So now that I've pickled it and stored it, I can now kind of retrieve the values in the DBM. So here I'm going to pretend I'm going to open up the DBM again, and I can kind of iterate through this. I can say for key in DB, print key and DB of the key. Okay, and so we have the three values. We have Cleese and Cleese.png, and the associated value is photo John Cleese. Jones.png, and the associated value is there. And then we have this key list, and the associated value is this string x80 and whatever, okay? So this is stored, but again, it's not in a form that we can really understand, okay? So what we have to do is we have to convert this back into something that we understand, okay? And so we call pickle.loads, okay? And load s will convert this thing, db list, back into a string, okay? Back into the list. So here, let me just, I think I can also just do pickle.loads. Yeah, so if you give it a byte object with these things here, this will recognize and say, oh yeah, we can convert this back, okay? So you can just kind of copy and paste the output here, and it will convert it back into the Python object, right? So it's kind of this, it's like a conversion thing, okay? So we can't store the list 1, 2, 3 directly. So things look really wild, okay? So if I do like pickle.dumps, and you wanted to store, say, a dictionary, okay? And I got a A is the value 123, and B is going to be the string house, and C is going to be, you know, list 1, 2, 3. Okay. Parentheses. Okay, it converts this, and there's some things that, like, okay, we can suddenly see the word house in there, but again, this is hard to read. Okay, it's not really meant to be understood, okay, by a human. But then again, you store it in that kind of pickled form, and then you call pickle load s. Okay, you paste in whatever it is, and it recreates the object, whatever it is there. Okay, so you can pickle a bunch of things. Okay, so you can pickle objects directly to a pickle file. All right, and you can kind of pickle a bunch of objects by grouping them together into a list or a tuple. So here I got object 1, which is this list, file 1, something else. Object 0. Object 1 is list 1, 2, 3. Object 2 is the string hello world. Okay, and then I'm going to say with objects.pickle. Okay, and then the arguments here will be write and binary. Okay, WB is going to be write binary, and we're going to call pickle dump. And here this dump, if you call dump without the dump s, it will store them directly into the pickle object form, okay? Versus converting it into a string, okay? So dump s turns it into a string that you can kind of put into a DBM, and here this will create basically a pickling object, okay? So this is .dump, and this will create a pickling object. And that's you know, not intended for you to interact with there. Okay, so here later on, if you want to retrieve these things, you call pickle.load. So not dump s or load s, but dump and load. Okay, and here, because we have 3 objects, we'll unpack them into 3 objects: x1, x2, and x3. And so here I can retrieve x1, x2, and x3, and these are exactly the files that we stored, okay, or the objects that we stored. Okay, and so that's all pickling here, and again, here's the values, what can be pickled and unpickled, and there's quite a bit that can be pickled, but you know, later on when we're dealing with, say, data frames and whatnot, you'll probably want to use like a CSV file or something for data frames and things like that. But other Python objects lend themselves quite well for pickling or being stored into a DBM. Okay, that's all I got for today. So we'll go ahead and wrap things up there, and I'll give you your last view quiz.